Hey YouTube, I'm Jonas. Welcome back to my channel. Today we're gonna solve the valid parenthesis. So we're given a string S containing just the characters in these 6 types, and we need to determine if the input string is valid. So the definition of valid is that if the open brackets are closed by the same type of brackets. So open brackets basically means this one, and this one. So the closing brackets basically are the corresponding brackets. It's this one, and this one. So the open brackets must be closed in the correct order, which means that if we have opening brackets like this one, and the closing brackets like this one, and opening square brackets and closing bracket, and they're in the correct order to match each other. So that's a valid input string. However, if we have opening bracket like this one and a square bracket and a closing bracket, so we cannot cancel out these two brackets because we have opening square bracket between them, so they are not in the correct order. So it's not a valid input string. Also, every closing bracket needs to have a corresponding open bracket of the same type. So basically, if the opening parenthesis is like this one, and the closing one is a square bracket, so they are not the same type. So that would not be a valid string. So let's take some example. The first example is making a lot of sense, right? So just have a opening parenthesis and the closing one, so they are the same type, so it's a valid string. And for second example, basically we have 3 sets of corresponding brackets, opening parenthesis, closing parenthesis, and opening square brackets and closing brackets, and the curly brace and a closing curly brace. So they are all closed in the correct order and they're all in the same type. So that's also a valid string. So the third example is just basically what I said in this one, right? So because the closing bracket is not matching the opening parenthesis, so it's not a valid input string. So we will start with the opening bracket. We may have like 1, 2, 3, 4, 5. We can add as many brackets as you want, as long as you eventually closing all of them. Like if we have these 5 opening parentheses, I will need to have 5 closing parentheses, like 1, 2, 3, 4, 5. Each one of them will be canceled out if they are the same type and in correct order. And if all of them are matching with each other, all the parentheses will be crossed out and the whole list will be empty. So that's how we know that the parentheses are all matched, telling us whether it's a valid string. So basically, we always wanted to deal with the top element of the list, right? Say we have a list, start with the opening parentheses and the square bracket and the curly brace. So we want to deal with the top of the list because if we want to close the parentheses, we need to match the upcoming one with the most recently added element. Say if the next element is the closing curly brace, we will pop out the most recently added element, which is the opening curly brace. So they're in the same type. One is opening and one is closing. So they are canceled out. Once they canceled out, the most recently added element comes to this opening bracket. Say the next element is the closing bracket. So they are in the same type, and one is opening and one is closing, so they can cross out as well. And then these 4 brackets are canceled out. The most recently added element is this opening parenthesis. So if our next element is the closing parenthesis, they are also in the same type, and one is open and one is closing. So all the elements are canceled out. This list becomes empty, and we will know that all the brackets are closed, and this is a valid input string. So basically, as we want to pop out the top element of the list, what data structure comes to your mind first? So the stack, right? So the stack is a LIFO data type, which means the last in element will be the first one to come out. So we want to deal with the most recently added element of the list. So stack structure will help us a lot. Also, how do we know which opening bracket should our closing bracket matches? So if the next element of the bracket is this closing parenthesis, and we will map it to the opening parenthesis. And if it's a bracket, we will map it to an opening bracket. If it's a curly brace, we will map it to a opening curly brace. So basically, it's just a hash map. When we visit a parenthesis, we will determine which types of it is the closing parenthesis and map it to the opening one, and to see whether this opening one is equivalent to the element that pops out from the list. So in this way, we can compare them and determine whether we can cancel them out. If we can't cancel them out, and we know that it's an invalid input string. All right, so let's code it up. So as we mentioned in the drawing, we need to use the stack data structure to implement this. So we will first have a stack. So basically in Python, we didn't have a library to implement the stack, so we will use the list to have the same effect as the stack. Then we will have a hash map, which is the close to open. This variable is going to be a dictionary. The closing parenthesis will map to the opening parenthesis, and the closing bracket will map to opening bracket, and the closing curly brace will map to opening curly brace. So basically, we will visit every element in the input string. So the time complexity will be O(n). If the element is in the close to open hash map, we will know that the current element is the closing bracket. At this point, if our stack is not empty, and the most recently added element of the stack equals to the opening parenthesis that the current closing parenthesis matched with. So basically, we will use stack at the index -1 to indicate the most recently added element of the list.
And we will use the element as the key to find the value in the close to open hash map, which will be the expected opening bracket to compare.
If they are the same, we will pop out the most recently added element of the stack. So if they are not matched with each other, we will just return false, because even one unmatched parenthesis in the string will lead to invalid. And if the element is not in close to open hash map, we will know that the element is the opening parenthesis, and we will basically just directly add them to the stack. And if we have visited all the elements in the string and we didn't return in the middle of the iteration, we will return true. But we need to be aware that if this stack is empty. So why that? Imagine we just have a one element input string, which is the opening parenthesis, in this for loop. Because it's not the closing bracket, we will into this condition and we will append this element into the stack, and we will not return false in the iteration. So when we get out from the for loop, basically if we just return true, the bracket is not closed, so the true will generate some error. So we want to check if the current stack is empty. If all the parentheses have been closed, the stack should be empty because every element has been popped out. Okay, let's see the result of our code. Okay, so basically we use the stack to solve this problem efficiently and it beats 100% users.